Welcome to homework.
So in this question, we're given the critical angle for total internal reflection at the boundary. And then this question asks us to find the Brewster's angle at this boundary, and we want to find one for each of the media. So before I start to do this question, I want to give a review of the total internal reflection, because this is a concept in chapter 23, and you may or may not still remember it. And then I'll do a quick review of the Brewster's angle before we get started to actually solve this question. So total internal reflection is when you have a media in 1 and you have a media in 2. So according to Snell's law, when you are passing from one media to the other media, you have n1 sine theta 1 equals n2 sine theta 2. The problem is when one angle is significantly larger, when one media has a significantly larger refractive index n than the other media. Say if n2 is significantly larger than n1, then what we'll see is that sine theta 1 will very quickly, it will have to exceed 1. In that case, total internal reflection will happen, because usually if we have light coming from a denser media, the angle will be larger when the refraction angle is larger than the incident angle. But then if we keep increasing this angle, the incident angle, at a certain point, because this angle is larger than this incident angle, at a certain point, the refraction angle will become 90 degrees. It will be like this, and it just can't increase anymore. So we call this angle the critical angle, because beyond this angle, or when you reach this angle, you will see no refracted light, and all light will have to be reflected, because this is 90 degrees, it cannot increase anymore. So that is also how we find the total internal how we find the critical angle for the total internal reflection. We do it by setting one of the sine to 1, because that is sine 90 degrees, not 1. So when theta 1 is 90 degrees and sine theta 1 is 1, we have sine theta critical equals n1 over n2. So that is the equation that gives us the total internal reflection critical angle. So here, when we know that the angle is 58 degrees, it's pretty much telling us what this ratio is. So that's total internal reflection. So what about Brewster's angle? Brewster's angle is an angle in that if you have this, and again, this is n1, this is n2, I'm assuming n2 is larger than n1. Brewster's angle is the angle in which case the polarization of the light in one direction will disappear. And that happens when the refracted light and the reflected light form an angle of 90 degrees. So this is theta 1, this is theta 1, and this is theta 2. Again, we write down Snell's law, n1 sine theta 1 equals n2 sine theta 2. But because this is 90 degree angle, we know theta 1 plus theta 2 equals 90 degree. So that also means sine theta 1 equals cosine theta 2. So and cosine theta 1 equals sine theta 2. So if we choose to plug in one of these, if we replace all sine theta 1 with cosine theta 2, what we will get by rearranging it is tangent theta 2 equals n1 over n2. So this is Brewster's angle we get if we have the light incident from a lower media to a higher index media. This is a Brewster angle when it goes from n1 to n2. So on the other way, if we have it the other way around, we can also have, if we plug this equation into it, then we have n1 cosine theta 2, n1 sine theta 1 equals n2 cosine theta 1. So then we have tangent theta 1 equals n2 over n1. So this is what happened if we have the light passing from n2 to n1. Or in other words, it's light passing from higher index to lower index. So anyway, right now, we already know the total internal reflection. We know theta c equals 58 degrees. And we're looking to find these two numbers. And this can be done by just try to represent the relationship of n1 and n2 by using the critical angle. So we have tangent theta 1 equals n2 over n1 equals 1 over sine theta c equals 1 over sine of 58 degrees. That is, it's probably easier if we, instead of having tangent sine 1 on one side, I just have sine 1 equals arctangent of n2 over n1. That is the easier way to write it. Then we have it equals to arctangent over 1 over sine critical angle. And then I plug in the number. It is 1 over sine 58 degrees. Then I enter the whole thing into the calculator. It gives me 49.7 degrees, which is 50 degrees. So that is for theta 1. And we can do the same thing for theta 2. We'll have theta 2 equals tangent, arctangent. This time we have n1 over n2. And now we have its arctangent of sine 58 degrees. And again, we plug in all the numbers. This gives us 40.3 degrees equals around 40 degrees. So we're asked to find the Brewster's angles for the boundary, give 2 and so 1 from each media. So we have theta 1, we have this number is 40 degrees. And this number is 50 degrees. Okay, so depending on which light, depending on where the incident light is, whether it's from the air to the water or from the water to the air, you will have an angle of 50 degrees or 40 degrees, and that is the answer the question wants from us. It wants one answer for each media. So the answer for the higher index media is 40 degrees, and the answer for the lower index media is 50 degrees.